The James Webb Space Telescope has stunned the world once again. This time it's not distant galaxies or nebulae stealing the show. Instead, it's our solar system's smallest and innermost planet, Mercury, that has captured our attention. The JWST has revealed something unexpected on the surface of this scorching world: bright, reflective areas that resemble diamonds scattered across its cratered landscape. These diamonds are not actual gemstones, of course. Scientists believe they are likely highly reflective metallic deposits. One leading theory suggests they are composed of silicon carbide, a compound known for its hardness and high melting point. This material could have been brought to the surface by volcanic activity or impacts from asteroids and comets. The presence of these reflective features is intriguing. It suggests that Mercury's geological history is even more complex than we previously thought. Further observations and analysis will be needed to confirm the composition of these diamonds and understand their origin. Mercury's surface is a harsh and unforgiving environment. Temperatures can soar to a scorching 800 degrees Fahrenheit or 430 degrees Celsius during the day due to the planet's proximity to the Sun. At night, temperatures plummet to a frigid -290 degrees Fahrenheit or -180 degrees Celsius, because Mercury has a very thin atmosphere to trap heat. These extreme temperature swings, combined with the constant bombardment of solar radiation, make it difficult for any spacecraft to survive on Mercury for extended periods. The JWST's observations, however, were made from a safe distance, allowing it to capture detailed images of the planet's surface without being exposed to these harsh conditions. The discovery of these shiny spots has sparked intense curiosity among scientists. Some theories suggest they could be remnants of an ancient global magma ocean that once covered the planet. Others propose they are evidence of ongoing volcanic activity deep within Mercury's interior. One of the most intriguing aspects of Mercury is its unusually large core. Relative to its size, Mercury has the largest core of any planet in our solar system. Scientists believe the core makes up about 85% of the planet's radius. This is significantly larger than Earth's core, which makes up only about 50% of our planet's radius. The composition of Mercury's core is still a subject of debate. However, scientists believe it is primarily composed of iron and nickel. The presence of a large iron-rich core explains Mercury's surprisingly strong magnetic field. This field, though much weaker than Earth's, is still strong enough to deflect the solar wind. The massive core has significant implications for understanding Mercury's formation and evolution. Some scientists theorize that a giant impact early in the solar system's history could have stripped away much of Mercury's outer layers, leaving behind the dense core we see today. Before the JWST, our understanding of Mercury was primarily based on data collected by two pioneering NASA missions, Mariner 10 and Messenger. Mariner 10, launched in 1973, was the first spacecraft to fly by Mercury. It made 3 close approaches to the planet. These flybys provided our first close-up glimpses of Mercury's surface. The images revealed a heavily cratered world, similar in appearance to our own moon. Messenger, launched in 2004, became the first spacecraft to orbit Mercury. It spent 4 years studying the planet from orbit. Messenger made numerous discoveries. It confirmed the presence of water ice in permanently shadowed craters at Mercury's poles. It also detected unexpected amounts of volatile elements like potassium and sulfur on its surface. These missions revolutionized our understanding of Mercury. They revealed a dynamic and complex world, far different from the barren and lifeless planet scientists had once imagined. Unmasking Mercury magnetic fields and volcanic pasts. Mariner 10's flybys of Mercury provided the first hints that the planet possessed a magnetic field. This was a surprising discovery. Scientists had not expected such a small planet to have a global magnetic field. Messenger's subsequent observations confirmed the existence of Mercury's magnetic field and revealed that it is offset from the planet's geographic center. This offset suggests that the field is generated by dynamo processes in the planet's liquid outer core. Both Mariner 10 and Messenger found evidence of past volcanic activity on Mercury. Images revealed vast plains of smooth volcanic material. These plains suggest that Mercury experienced periods of intense volcanic eruptions early in its history. These eruptions would have resurfaced much of the planet, covering older craters. These findings, along with the discovery of potential volcanic deposits like the shiny spots observed by JWST, paint a picture of a planet with a surprisingly active geological past. A harsh reality, extreme temperatures, and a thin atmosphere. Mercury's proximity to the Sun results in extreme surface temperatures. The planet has the largest diurnal temperature variation in the solar system. Daytime temperatures can reach a scorching 800 degrees Fahrenheit. At night, temperatures plummet to minus 290 degrees Fahrenheit. This is due to Mercury's very thin atmosphere, known as an exosphere. It provides little to no insulation. The harsh conditions make it a challenging environment for life. Bepi Colombo unveiling Mercury's secrets. The European Space Agency and the Japan Aerospace Exploration Agency have teamed up on a mission to further unravel the mysteries of Mercury. The Bepi Colombo mission, launched in 2018, consists of two spacecraft, the Mercury Planetary Orbiter and the Mercury Magnetospheric Orbiter. Bepi Colombo is currently on its way to Mercury. It is scheduled to arrive in orbit around the planet in December 2025. The two spacecraft will work together to study Mercury's composition, geology, magnetic field, and exosphere in unprecedented detail. The mission's findings are expected to provide crucial insights into Mercury's formation, evolution, and its place in the solar system. Scientists are particularly interested in learning more about the planet's internal structure, its magnetic field generation, and the potential for water ice and other volatiles at the poles. A cosmic dance. Mercury's unique orbit and rotation. Mercury's orbit around the Sun is highly elliptical, meaning its distance from the Sun varies significantly throughout its year. At its closest point, perihelion, Mercury is only 29 million miles or 46 million kilometers from the Sun. At its farthest point, aphelion, it is 43 million miles or 70 million kilometers away. Mercury also has a unique rotation period. It rotates on its axis 3 times for every 2 orbits around the Sun. This 3-to-2 spin-orbit resonance is caused by the gravitational influence of the Sun on Mercury's elongated shape. This unusual rotation pattern results in a day on Mercury, from sunrise to sunrise, lasting twice as long as its year, 1 orbit around the Sun. Mercury's unusual orbit and rotation have profound effects on its surface conditions, contributing to the extreme temperature variations and the planet's overall dynamic environment. The nitrogen enigma clues to a bygone atmosphere. Messenger discovered significant amounts of nitrogen in Mercury's exosphere. Nitrogen is volatile and should have been lost early due to weak gravity. This suggests Mercury once had a much thicker atmosphere. The atmosphere could have been lost due to weak gravity, solar wind, and impacts.